welcome back. So far we have learned about that if a current waveform or a function is given or a voltage waveform or a function is given, how we can find the other parameters. Okay, like current is given, how we can find the voltage for the capacitor and inductor. Similarly, if the voltage is given, how we can find the current for the capacitor and inductor, how we can find the energies and beyond that. Now let's have a look at if we have an RLC circuit, an actual circuit. So how we can analyze that circuit? Okay, to find basically, let's say the stored energies by the energy storage elements. Okay, or like beyond the powers. Okay, by the resistive and the energy storage elements and beyond. Okay, so if you have a circuit, so how we can find that? So the question is here: find the energy stored by each energy storage element in the circuit. So if we have a such circuit, so remember we need to find basically the energy. So energy storage elements in this circuit are basically two, a capacitor and an inductor. And we know that for the capacitor, the energy stored is half of C voltage drop across the capacitor square. And energy stored in inductor is half of L, okay, current flowing through the inductor square. Okay, so these are the basic formula to calculate the energies. It means if I want to find out what is the energy stored by this capacitor, so I need to know what is the value of this capacitor, which I know that. Then I need to find out what is the voltage drop across this capacitor, right? Then I need to take it square. So like what is the voltage drop here? Similarly, if I want to find out what is the energy stored by this capacitor, I need to find out what is the voltage drop here across this capacitor. Okay, like let's call this VC2 and let's call this VC1. Now for the inductor, I want to find out the inductor energy, so I need to find out half L, the value of inductor is given, let's say 2 milliamp Henry. I need to find out what is the current flowing through this inductor, like what is the current, this one, let's call this IL1. Similarly for this one, L2, what is the current flowing through this one, let's call this IL2. So if we know these things, okay, the currents and the voltage drop across the inductors, then we can easily find the energies. Now to further solve this circuit, so basically to find out these voltages and these currents, okay, we will assume that the capacitors, the energy storage elements are basically working in the steady state. Okay, so in the steady state, what will we do? Always for the analysis to find out basically the voltage and currents, we will assume that the capacitors are basically open circuit. Okay, so basically I replace all the capacitor with an open circuit. Inductor basically become short circuit. So basically I will replace all the inductor with the short circuit. So with this assumption, we will redraw our circuit. So let's draw that, how our drawn circuit will look like. Okay, this is a voltage source. Then here I have a 6 ohm resistor. After that, there was a capacitor, so we will replace that capacitor with an open, and we need to find out what is basically the voltage drop here. Then we have inductor, so we will replace the inductor with a short circuit, and we need to find out what is the basically current going through this one. All right, moving on. Okay, what we have next, we have basically at this node a current source. So let's draw that. The value of that current source is 3 ampere. Then we have a 3 ohm resistor. Then we have second inductor. So second inductor also replace short circuit, and we need to find out what is this current, IL2. There is a capacitor, we will make it open circuit. So we need to find out basically what is the voltage drop here. And then another resistor. So basically this is a circuit that we have to solve, okay, using the techniques, any technique, systematic techniques we have learned, nodal mesh, superposition, Thevenin, etc. And we need to find out basically what is the voltage drop across the capacitors and what is the current flowing through the inductors. So we can like analyze this circuit again using different ways. Okay, so at the end our target is to basically find the current and voltages. Okay, so the one easiest way could be Like if we just simply write basically a nodal here, for example at this point, let's call this node A, or we can also do the mesh. Okay, both ways can be done. Okay, so let me do this with the nodal. So if we write the nodal equation here, okay, so what will be like nodal all currents leaving. Okay, my purpose is to basically find the voltage or current so that I can find the rest of the things. So this current will be leaving, so what will be that? VA minus, what is the voltage here? 9 volt, right? Divided by this resistor 6. Then this current will be leaving, so that will be minus 3 ampere. Alright, then this current will be leaving, what will be that? Again VA, okay, minus, okay, so this current is basically going through this one and reach here. So because the second end is basically ground, so VA minus 0 divided by what is the current, sorry, resistor 6 plus 3, 9 is equal to 0. We can simplify this one. Okay, and like how we can do the simplification, this is just a one variable equation, so we can multiply this whole, okay, with for example 54. Okay, why 54? We need to find the common of this. So what that will give me? So 54 divided by 6, that will give me 9. So 9 times VA minus 81, right? Minus, okay, 54. We can multiply with 54, even we can multiply with 18. Okay, like we need to find out the common multiplier of those. Okay, whichever you like. Okay, so 54 times 3, that will give me minus 162. Then 54 divided by 9, that will be 6. So 6 times this plus 6 times of VA is equal to 0. So 9 and 6, that will give me 15 VA, and these two will be added. So 81 plus, that will give me 243. So value of VA basically become 243 over 15, right? And if we just simplify this one, this will like divided by 3. Okay, so that will become 3 times 8 and 3 times 1 and 3 times 5. Okay, so 81 over 5 volt. Okay, that will be the voltage at this location. So if you know this voltage at this location, okay, we can find the current, right? Like what is this current flowing through this, right? How we can find that current now? If you know this voltage, okay, we can find easily, right? IL1, like this current, okay, what will be that? This current will be like this voltage minus this voltage, right? Because the flow of current is this one. So 9 minus, what is the voltage here? 81 over 5, okay? 81 over 5, that is 16.2, right? Divided by resistor. What is the resistor? 6. So if we just simplify this, so the value of IL1 comes out to be minus 1.2 ampere. Okay, so this is the current IL1. Similarly, we can easily find what will be the current IL2. Current IL2 is the current flowing through this branch, right? So IL2 will be this voltage, which is basically 18 over 5 or 16.2 minus this voltage, what is 0, divided by the resistor. What is the resistor? 6 plus 3, 9. So 16.2 divided by 9, that will give me a current of 1.8. Okay, why I'm finding these things? So that we can calculate the energy later on. So what is left now? We are left with the voltage drops, right? So let's find out that what could be the voltage drop. VC2, for example. So if I look at the circuit, VC2 is the voltage drop between two nodes. So this will be the same voltage drop across this branch, 6 ohm. So if we can find what is the voltage drop across 6 ohm, that will basically give me the value for the voltage drop across the VC2, right? So what is the voltage drop across 6 ohm? Voltage drop across 6 ohm will be, if we know the current, like what is the current flowing through this one? So this is the same current, IL2 basically flowing through this one. So value of resistor multiply with the current. What is the value of current? 1.8. So 6 times 1.8, that will give me 10.8 voltage. That is the VC2. Okay, voltage drop across capacitor 2. So then we are left with what? We are left with basically the voltage drop across the capacitor 1. Okay, so let's have a look how we can find that. So voltage drop across the capacitor is basically coming here, right? So what we can do here, we can simply define a loop here. Okay, for example, okay, if we write a KVL for this loop, we can easily find the current here, the voltage drop here. So that will be basically -9 plus the voltage drop here. What is the voltage drop here? 6 times the current. What is the current flowing through this one? That is IL1. What is the value of IL1? -1.2. So -1.2, okay, plus VCE1 is equal to 0. So VCE1 will be basically, just simplify this one, right? So 6 times 1.2 plus 9, okay, so that will give me basically 16.2. Okay, so basically VC1. Okay, so voltage drop here, okay, will be VC1, or we can find it directly also. Basically voltage drop here is the voltage at this node, right? So this node is basically connected here, and this node is basically what? Okay, same voltage. Okay, so we can get it directly also. Okay, 18.5. Okay, so that will be VC1. So we have found the value of all the voltages, we have found all the currents. Now we can easily calculate the energies. Okay, so let's do that. So let's calculate the energy for the capacitor 1. So that will be half of C. Okay, value of the capacitor. What is the value of capacitor? 20 microfarad. What is the voltage for this one? 16.2. So half of C, 20 microfarad. Voltage 16.2 square. All right. So if you plug in the numbers, that will give me 2.62 millijoules. What is the energy for the capacitor 2? Half value of capacitor. What is the value of capacitor here? 50 microfarad. What is the voltage? 10.8. So 50 microfarad, voltage 10.8 square. So if we simplify this one, that will give us answer of 2.92 joule. Energy for the inductor 1, half of L. What is the inductor value? 2 millihenry. So 2 millihenry. What is the current flowing through this one? IL1. What is the value of IL1? -1.2. So 2 millihenry times 1.2 square. So if you simplify this one, it will give me 1.44 millijoule. Okay, so this is also a millijoule. Energy for the inductor 2, so that will be half. Okay, inductor 2, what is the inductor 2 value? 4 millihenry. What is the IL2? 1.8. So 4 millihenry, 1.8 square. Okay, so this will give me answer of 6.48 millijoule. Okay, so if you want to find the total energy, okay, by this energy storage elements like total energy, so that will be basically sum of all this energy. Okay, so this is how we can find the total energy for this case. All right, thank you so much.